Hi all, I am K. Surya, working as Assistant Professor in the Department of ECE at SNS College of Technology. So in this video, let us see about torque meters, which is an important instrument used in measurement and instrumentation systems. So in many engineering applications, it is essential to apply the correct amount of rotational force. If a bolt or a screw is tightened too much, it can damage the components, and if it is tightened too little, it can lead to loose connections and system failure. So therefore, accurate torque measurement is crucial in industries such as automotive, aerospace, manufacturing, electronics, and medical devices. In this video, we will see about what is torque meter, its working principle, types, and applications. So before understanding the torque meter, we need to consider a common problem. So imagine tightening a screw without knowing exactly how much force is being applied. Over tightening can strip threads, crack housings, and permanently damage the components. Under tightening can result in loose joints, vibrations, and even catastrophic failures during operation. Human judgment alone is often not precise enough to determine the exact turning force required in modern engineering systems. This creates the need for a reliable instrument that can accurately measure the torque. Torque meters solve this problem by providing precise measurements of rotational force, ensuring safety, reliability, and product quality. A torque meter is a precise instrument used to measure rotational force, commonly known as torque. It measures the twisting force that is applied to a shaft, fastener, motor, or mechanical component. The primary purpose of the torque meter is to ensure that every component is assembled according to its specified torque value. This helps prevent failures caused by either excessive or insufficient tightening. We can think of a torque meter as a weighting scale for twisting force. Just as a weighting scale measures weight, a torque meter measures rotational force and converts it into a readable value of the user. So let us see about the working principle of torque meters. So most modern torque meters operate based on the straight gauge principle. When torque is applied to a shaft, the shaft experiences a very small deformation of twist. Although this deformation is extremely small and invisible to the naked eye, it can be accurately detected using strain gauges attached to the shaft surface. A strain gauge is a thin wire or metallic grid whose electrical resistance changes when it is stretched or compressed. As the shaft twists, the strain gauges also deform, causing a change in resistance. This resistance changes is detected using a Wheatstone bridge circuit, which is highly sensitive to small electrical variations. The resulting signal is then amplified and converted into a torque reading that can be displayed in real time. This principle allows the torque meters to measure even very small amounts of torque with high accuracy. Next, let us see about the measurement process step by step. So first the torque is applied to the shaft. Due to this applied torque, the shaft undergoes a slight deformation. The strain gauges bonded to the shaft detect this deformation by experiencing stretching or compression. As a result, their electrical resistance changes. So this change in the resistance is converted into an electrical signal by the Wheatstone bridge circuit. The signal is then amplified and processed to generate a torque reading. So the entire sequence happens almost instantly, allowing real-time monitoring of torque. A simple analogy is Stretching a rubber band. When a rubber band is stretched, its physical properties will change. Similarly, when a shaft twists, the strain gauges experience changes that can be measured electrically. So the successful use of the torque meters involves several stages. The first stage is design and ideation, where engineers identify the areas requiring the precise torque control. The second stage is sensor selection, where an appropriate torque meter is chosen based on the speed, torque range, operating conditions, and application requirements. The third stage is integration, where the torque meter is installed in the machinery, production lines, testing equipments, or assembly systems. And the final and the most important stage is the calibration stage, where it ensures that a torque meter provides accurate measurements by comparing its readings with certified reference standards. Without proper calibration, measurement accuracy cannot be guaranteed. So torque measurements play a critical role in many real world applications. So in the automotive industry, correct wheel lug nut torque ensures vehicle safety and prevents wheel failures. In aerospace systems, every fastener must be tightened to precise specifications because even a small error can compromise aircraft safety. In medical devices, surgical instruments and implantable devices require accurate torque during assembly to ensure reliable performance inside the human body. In electronics manufacturing, tiny screws and fasteners used on circuit boards can be damaged if excessive torque is applied. So these examples demonstrate how torque measurement directly affects safety, reliability, and performance. So one important type of torque meter is the rotary torque meters. So they are designed to measure torque in rotating shafts. They can measure both rotational force and shaft speed simultaneously. Using these measurements, parameters such as power output and efficiency can also be calculated. Rotary torque meters provide continuous real-time monitoring while the shaft is rotating, making them highly useful in dynamic applications. Another important type is the reaction torque meter. Unlike rotary torque meters, reaction torque meters are used for stationary or non-rotating systems. They measure the reaction force generated when torque is applied to a component. Since they do not contain moving parts, they are highly durable, reliable, and cost effective. Reaction torque meters are widely used in motor testing, calibration laboratories, robotics, and fastener torque verification systems. Torque meters are used in wide variety of industrial and commercial applications. For in manufacturing industries, they are used for quality control, process monitoring, and product testing. During testing and validation, torque meters help verify whether motors, pumps, actuators, and mechanical systems meet their specified performance requirements. In robotics, torque feedback allows the robots to handle delicate objects safely without applying excessive force. Torque meters are also found in consumer products such as power tools, household appliances, and assembly equipments where proper torque ensures product reliability and longer service. Their ability to provide accurate and real-time measurements makes them essential in modern engineering systems. So let us summarize what you have seen today. So a torque meter is a precision instrument used to measure rotational force or torque. So they help ensure proper assembly, improve product quality, and ensure operational safety. Two major types are rotary torque meters, which is used for rotating systems, and reaction torque meters, which is used for stationary systems. Thank you for watching this video.